All right. Integration by trigonometric substitution. So this is the third type of integration technique that we are exploring in our Calculus 2 course. And in this unit, in this section, in fact, we'll be looking at the integrals in the form a squared minus x squared, a squared plus x squared, and x squared minus a squared. So if you have any integral in these three forms, a squared minus x squared, or a squared plus x squared, and x squared minus a squared, then we can use trig substitution. And here we have the quick note for that. If you have a squared minus x squared, then we use sine theta equal to x over a, which is same as x equal to a sine theta, which is same as x equal to a sine theta if you multiply on both sides by a. That means in this one, the substitution will be x equal to a sine theta. If the integral involved a squared plus x squared, then we substitute tangent theta equal to x over a, or x equal to a tangent theta. And for the integral involving x squared minus a squared, we can use secant theta equal to x over a, which is same as x equal to a secant theta. X equal to a secant theta. Now, when you look at these three substitutions, you can see sine equal to x over a, tangent equal to x over a, secant equal to x over a. So for all x over a, we either use sine or tangent or secant. Now, one thing you need to do is you have to remember your SOHCAHTOA from your trig class, because in order to perform the integration, you'll construct and complete the right triangle based on the substitution. Whatever substitution you are making, based on that, you are constructing a right triangle. So what you have to do is you always need to make a right triangle like this. You have to label the 90-degree or right angle properly. And then you must have your theta. You must have your right angle, or you must label your right angle and then theta. And based on your substitution, write the two sides. For example, if you're working on sine theta equal to x over a, you know that sine is opposite over hypotenuse. So here is your opposite, here's your hypotenuse. So if I am taking sine, what you'll do is you'll write your x here and a here, because sine theta equal to x over a, it is same as opposite over hypotenuse, which is opposite is x, hypotenuse is a. Then you'll find the missing side. You have to find the missing side of the triangle using Pythagorean identity. So this missing side of the triangle will be square root of a squared minus x squared. So after you make the substitution, you have to construct and complete the right triangle like this. This is for the first case. Okay, I'm doing it for the first case. When sine theta equal to x over a, or x equal to a sine theta, this will be your triangle. You'll find the missing side. Missing side will be square root of a squared minus x squared. And you are going to use this information to perform the substitution, and then you'll evaluate the integral. So that is the fundamental idea in integration by trigonometric substitution. Example, evaluate the indefinite integral 5 over 16 minus x squared raised to 3 over 2. When we look at this integral carefully, we'll see that in the denominator, we have 16 minus x squared. We have 16 minus x squared in the denominator, which is same as 4 squared minus x squared, which is like a squared minus x squared. And we know that if the integral is in the form a squared minus x squared, we'll use the trig substitution with x equal to a sine theta. So in place of a, I have 4, so it will be x equal to 4 sine theta. So that is the substitution you are going to make. Like U substitution, this is the trig substitution. In place of x, you are substituting 4 sine theta. Now, if you try to find the derivative of x with respect to theta, you'll see that dx equal to 4. Derivative of sine is cosine theta. In derivative, we write dx over d theta. And if you move over d theta, it will be 4 cosine theta d theta. So we are performing this substitution. X equal to 4 sine theta. And if you differentiate that, you get dx equal to 4 cosine theta d theta. That will help you to remove this dx later on. Because we are making the trig substitution, this question which is given in terms of x must be changed into a question in terms of theta after performing the trig substitution. Now we are going to construct a right triangle to represent x equal to 4 sine theta. So let's do that. You'll construct a right triangle because we are performing the trig substitution. So you need the right triangle with the reference angle theta and a right triangle there. Here we have x equal to 4 sine theta, meaning of that is sine theta is equal to x over 4. That is the meaning of that. Sine theta equal to x over 4. So sine is opposite over hypotenuse. So x is the opposite. 4 is the hypotenuse. And if you want to use the Pythagorean identity and find this missing side will be square root of 16 minus x squared. Now we are going to make the substitution in this integral. So if we make the substitution, let's see what we get. Now what I'm getting is, in the numerator there is 5 divided by 16 minus, there is x squared. X is 4 sine theta. When you square 4 sine theta, it will be 16 sine square theta. 16 sine square theta raised to 3 over 2. And this is times dx, or there is a dx over here. And value of dx is 4 cosine theta d theta. So dx is 4 cosine theta d theta. So we perform the substitution. And now you can see the question which was given in terms of x is now in terms of theta. Now you can see that it looks a little more crazy compared to the given question, but we are going to simplify this and make it neat. Let's see what we get. In the numerator, you can see we have 5 times 4, which is 20 cosine theta d theta divided by, in the denominator, now you have to be careful in the denominator. In the denominator, there is a 16, which is a common factor. And then when you factor 16 out, you'll get 1 minus sine square theta. And all this has the power 3 over 2. Okay, let's simplify this again. This is equal to integration of 20 cosine theta d theta over, now here you have 16 raised to 3 over 2. Meaning of that is 16 raised to power 1/2, that is the square root of 16, which is 4, and you are cubing it. 4 cubed is 4 times 4 times 4, which is 64. 64. And then here we have 1 minus sine square theta. 1 minus sine square theta is cosine square theta. It is power 1/2, that is the square root of cosine square theta. That is cosine theta raised to 3. Cosine theta raised to 3 is cosine cube theta. So that will be equal to, now if we simplify this, let's see what we get. We get 20 over 64. 20 over 64, you can reduce that. You can divide both numerator and denominator by 4. So 4 times 5 is 20. 4 times 16 is 64. So that becomes 5 over 16. And then integration of cosine theta over cosine cube theta will be cosine square theta in the denominator, which is same as secant square theta d theta. And that is equal to 5 over 16. From calculus 1, you know that the integration of secant square theta is tangent theta plus, this is the indefinite integral, so we need the constant of integration plus c. So here we got the answer in terms of theta, but the question is in terms of x, so we are going to resubstitute the value of theta and we'll get the answer in terms of x. So that means our final answer will be 5 over 16 tangent theta. From this triangle here, from this right triangle, tangent is opposite over adjacent. So it will be x over the square root of 16 minus x squared, x over the square root of 16 minus x squared plus c, which can be written as, in the numerator you can write 5 times x, 5x. In the denominator, 16 times the square root of 16 minus x squared plus c. So that is the result of this integration. Example, evaluate the indefinite integration of the square root of 1 plus 9x squared dx. Now, if we look at this integral carefully, it has the form 1 plus 9x squared, which is same as 1 plus 3x quantity squared, which is very similar to 1 is same as 1 squared. So this is same as a squared plus x squared. In place of a, I have 1. In place of x, I have 3x. That means what you know is whenever we have the integral in the form a squared plus x squared, we make the substitution x equal to a tangent theta. Substitution used to be x equal to a tangent theta. So we are going to begin with this one, x equal to a tangent theta. So let x, in place of x, now I have 3x. So I'll write 3x equal to a tangent theta is 1. 1 times tangent theta is tangent theta. So we need to make this substitution, 3x equal to tangent theta. That means if I want to find the derivative, then what I'm getting is 3 dx equal to derivative of tangent theta is secant square theta. Then if I move that theta to the other side, d theta to the other side, it'll be just like that. Because I'm making the substitution for dx, I have to find dx only. So divide on both sides by 3. You get dx equal to 1/3 secant square theta d theta. Now, if you look at the first line, we have 3x equal to tangent theta. Meaning of that is tangent theta equal to 3x over 1. That is the meaning of that. Tangent theta equal to 3x means 3x over 1. So that I can write in the form of a ratio and I can complete that right triangle. So let's draw the right triangle. If we draw the right triangle like this, we can have our reference angle theta here, right angle here, and we have tangent theta. Tangent is opposite over adjacent. So opposite is 3x, adjacent is 1. So we write 3x here, 1 here. 3x here, 1 here. And we'll find the missing side. The missing side of the triangle will be, you can see here we have 3x, here we have 1. So it will be square root of 1 plus 9x squared. So we constructed the triangle and we found the missing side of the triangle. Now we are ready to make the substitution. Now we are going to make the substitution to this integral, and let's see what we get by making that substitution. Now we have the integral of, here we have square root of 1 plus 9x squared. So if you look at this integral carefully, it is like square root of 1 plus 9x squared over 1. If there is no denominator, it's like over 1. So if you look at this one, it is square root of 1 plus 9x squared over 1. Square root of 1 plus 9x squared over 1. If you go to the triangle now, if you look at this triangle, square root of 1 plus 9x squared over 1 is same as hypotenuse over adjacent side. And you know that hypotenuse divided by the adjacent side is a secant. So square root of 1 plus 9x squared over 1 is this quantity, the hypotenuse, divided by 1, which is secant theta. That is secant theta. Multiplied to, now here we have dx, and dx is 1/3 secant squared theta d theta. 1/3 secant squared theta d theta. Okay, that is equal to, we have the integration, but before that, I can pull that constant out. 1/3 is a constant. I can pull that out. You have secant theta multiplied to secant squared theta is secant cube theta. Secant cube theta d theta. Now we get the secant cube theta. We can use the reduction formula for the secant cube theta. If you remember the secant integration of secant cube theta, we have secant raised to nx dx, the reduction formula, is equal to secant raised to n minus 2x tangent x divided by n minus 1, then plus n minus 2 over n minus 1 times the integration of secant raised to n minus 2x dx. We are going to use that substitution here, or that reduction formula. 1/3. So if I use the reduction formula, in place of n, I have 3. So 3 minus 2 will be 1. So it will be secant x tangent x over 3 minus 1, that will be 2. Secant x tangent x over 2. Secant x tangent x over 2. Then we have plus n minus 2. 3 minus 2 is 1 over 3 minus 1, that is 2, times the integration of secant raised to n minus 2. Here is 3. 3 minus 2 is 1. So it will be secant theta d theta. One important thing to note here that I'm making a mistake. This is not x, this is theta. Secant theta, tangent theta. Okay, let's go to next step. Here we have 1/3. If I distribute that, there is 2 in the denominator. So it will be 3 over, there is 2 in the denominator. So that will be 1 over 6. 1/3 times 1/2. 1/3 times 1/2 is 1/6. 1/6 secant theta times tangent theta, then plus 1/3, and here is also half. 1/3 and half, that will give you 1/6 again. 1/6. And from calculus 1, you know the integration of secant theta. Integration of secant theta is natural log of secant theta plus tangent theta plus c, the constant of integration, because this is the indefinite integral. So this is the answer in terms of theta, but the question is given in terms of x, so we have to resubstitute using this triangle and write our final answer in terms of x. So this is equal to 1/6 secant theta. Secant is hypotenuse over the adjacent side. So it will be square root of 1 plus 9x squared over 1, which is square root of 1 plus 9x squared. Multiplied to tangent theta. Tangent theta is 3x over 1, which is 3x. Then plus 1/6 natural log of secant theta. Secant theta is square root of 1 plus 9x squared over 1, which is square root of 1 plus 9x squared, plus tangent theta. Tangent theta is 3x over 1, which is 3x, then plus c. Here we have 1/6 of 3x, which is same as x over 2. X over 2 times the square root of 1 plus 9x squared, then plus 1/6 of the natural log of the absolute value of 1 plus 9x squared plus 3x plus c. So that should be the value of the indefinite integral given here. Example, evaluate the definite integral 0 through 1 dx over 1 plus x squared quantity squared. So when we look at this integral carefully, we have the quantity 1 plus x squared in the denominator. So it involves 1 plus x squared. Let me write that here. 1 plus x squared, which is same as 1 squared plus x squared, and it resembles a squared plus x squared. And we know that if an integral involved x squared plus a squared, we make the substitution x equal to, we use this substitution, x equal to a tangent theta to evaluate the integral. So we are going to use that substitution and evaluate this definite integral. So let's do that. Let x equal to a tangent theta. In place of a, I have 1. So 1 times tangent theta is tangent theta. So x equal to tangent theta is the substitution that we are making. Now let's find the derivative. Dx is equal to the derivative of tangent theta is secant square theta d theta. Also, if you analyze this carefully, this is same as tangent theta is equal to x means x over 1. So we can use this to construct the triangle. So let's do that. Let's make a right triangle and label that trig ratio over here. We construct the right triangle. We label the angles now, right angle and also the reference angle. So over here, the reference angle. Here we have the right angle. Now tangent is x over 1. Tangent is opposite over adjacent. So x is here, 1 is here. And then we'll find the missing side. Missing side will be 1 plus x squared. You can see this quantity 1 plus x squared, square root of 1 plus x squared. 1 plus x squared is there in the integrand. So once we have all this, now we can perform the substitution. Now if we try to substitute, we have dx in the numerator. Dx is secant square theta d theta. Secant square theta d theta divided by 1 plus x squared. 1 plus x is tangent theta. Square of that will be tangent square theta. And then there is a quantity squared. So we make that substitution. Let's simplify one step further and see what we get. Secant square theta d theta divided by, now in the denominator, 1 plus tangent square theta is secant square theta, and you are squaring it. So it becomes secant raised to 4 theta. So this will be equal to the integration of secant square theta divided by secant raised to 4 theta is 1 over secant square theta, or that is cosine squared theta d theta. And in order to integrate cosine squared theta, we use the half angle formula, which is cosine squared theta is 1 plus cosine 2 theta over 2 d theta. That half is a constant, you can pull it out. Now integration of 1 with respect to theta is theta plus integration of cosine 2 theta is sine 2 theta over 2 which is equal to, if I distribute that half, it will be half theta plus half of, there's also half over there. So half of half will be 1/4 sine 2 theta, which is equal to half theta plus 1/4. If we use the double angle formula for sine 2 theta is 2 sine theta cosine theta. So we get the value of the integral as half theta plus 1/4. And here you'll have 2 sine theta cosine theta, which will also be half sine theta cosine theta. So this is equal to, you have a half theta. Now we have to write theta in terms of x. You can see here, tangent theta is equal to x. That means theta will be equal to inverse tangent of x. That will be inverse tangent of x. And then plus, you have half sine theta. Sine is opposite over hypotenuse. So it will be x over square root of 1 plus x squared. X over the square root of 1 plus x squared times cosine theta. Cosine is adjacent over hypotenuse. So it will be 1 over that. 1 over the square root of 1 plus x squared, which is equal to half tangent inverse x, then plus over here in the numerator 1 times x times 1, that is x, divided by 2 square root of 1 plus x squared times square root of 1 plus x squared is simply 1 plus x squared. So we got the result in terms of x, but this is the definite integral. So we have to use the fundamental theorem of calculus and evaluate between 0 and 1. So we need to evaluate this one between 0 and 1, between 0 and 1. So first we plug in the upper limit 1. If we plug in 1, it will be half tangent inverse 1, half tangent inverse 1. Then plus, if I plug in 1 here, it will be 1 over 2 times 1 plus 1 squared. That is 1 plus 1. So by plugging in 1, we get half tangent inverse 1 plus 1 over 2 times 1 plus 1. Now we plug in 0. So it will be minus half tangent inverse 0, then minus. We are also plugging 0 here, so that will be 0 over 2 times 1 plus 0, which is equal to, now tangent inverse 1 is pi over 4. Half of pi over 4 is pi over 8. Plus 1 over 2 times 1 plus 1. That is also 1 over 2 times 2, which is 4. Then half of tangent inverse 0. Tangent inverse 0 is 0. So 0 times half, that will be 0. I don't have to worry about that now. 0 divided by this one is 2. 0 divided by 2, that's also 0. So last two terms are 0. So the only result is pi over 8 plus 1 over 4. So this is the value of the definite integral given here. Example, evaluate the definite integral 3 through 6 square root of x squared minus 9 over x dx. So looking at this integral, this integral involve x squared minus 9, which is same as x squared minus 3 squared, and this resembles x squared minus a squared. Because the integral involve x squared minus a squared, we can evaluate the integral by making the substitution x equal to a secant theta. X equal to a secant theta. So we are going to make this substitution and solve this integral. Let x equal to a secant theta. In place of a, we have 3. So x equal to 3 secant theta. Now if we find the derivative, dx is equal to 3 is a constant. Derivative of secant theta is secant theta tangent theta. Secant theta tangent theta, then d theta. Now, if we look at this substitution that we have made here, we can write this as secant theta is equal to x over 3, or you can also write cosine theta equal to 3 over x, because secant and cosine are reciprocal of each other. Now we are going to construct a triangle with this information, secant theta equal to x over 3 or cosine theta equal to 3 over x. We are going to represent that in a right triangle. So let me draw that right triangle here. Suppose that's my right triangle with the reference angle theta and this angle as a right angle. Because cosine theta is 3 over x, cosine is adjacent over hypotenuse. So we can write 3 here and x here. Now using the Pythagorean relation, we are going to find the missing side of the triangle. The missing side of the triangle, the third side will be square root of x squared minus 9. Square root of x squared minus 9. Now we'll be using this information to make the substitution for this one, for the given integral. Okay, let's make the substitution. We have the integral square root of x squared minus 9 over x, that is this side divided by this one, that is opposite over hypotenuse. And opposite over hypotenuse is sine theta. So that is sine theta. Then we have dx, and dx is 3 secant theta tangent theta. 3 secant theta tangent theta d theta. Let's simplify this a little bit. We have integration of sine theta. 3 is a constant, we can take that out. Secant theta is 1 over cosine theta times tangent theta d theta. So we are just simplifying the integrand there. That is equal to, we can keep that 3 outside. And over here we have sine over cosine. Sine theta times 1 over cosine theta is sine over cosine, which is tangent. Multiplied to another tangent theta is tangent is square theta. Tangent is square theta d theta. That is equal to 3. Integration of tangent is square theta. We cannot find the integration of tangent is square theta directly. So we are going to change this to secant. So tangent is square theta is secant is square theta minus 1 d theta. which is equal to 3. Integration of secant squared theta is tangent theta. Then minus integration of 1 with respect to theta is theta. That is equal to 3 tangent theta minus 3 theta. So we have the answer in terms of theta. Now we have to change this back in terms of x, because the problem is given here in terms of x. That is equal to 3 times tangent theta. Tangent is opposite over adjacent, so it will be square root of x squared minus 9 over 3, square root of x squared minus 9 divided by 3, then minus 3 theta. We have cosine theta equal to 3 over x, so theta will be cosine inverse 3 over x. Cosine inverse 3 over x. Or you can also use the first one, and you can write theta equal to secant inverse x over 3. It's the same thing. Now we have the answer in terms of x, but this is the definite integral, so we have to evaluate between the proper limits. So in next step, I'm going to write those limits. In the first term, we have 3 in the numerator and 3 in the denominator with multiplication, so we can cancel that. So we have square root of x squared minus 9 minus 3 cosine inverse 3 over x, and this expression must be evaluated between 3 and 6. Between 3 and 6. So we are going to use the fundamental theorem of calculus and simplify that. That is, we plug in the upper limit, we subtract and plug in the lower limit. So let's see what do we get by doing that. That is equal to, okay, we are plugging in upper limit. That is, first we need to plug in 6. So if we plug in 6, 6 squared is 36. 36 minus 9 is 27. So that becomes the square root of 27. Then we have minus 3 cosine inverse. If we plug in 6, it will be 3 over 6, which is half. Cosine inverse half. So that is what we get by plugging in upper limit. Now we subtract and plug in lower limit. Lower limit is 3. If we plug in 3 here, 3 squared is 9. 9 minus 9 is 0. Square root of 0 is 0. 0, then minus 3 cosine inverse. This will be 3 over 3. 3 over 3 is 1. Okay, now square root of 27, it can be written as 3 root 3 minus 3 times cosine inverse half. Cosine inverse half is pi over 3. Because cosine pi over 3 is half. Then minus, we are subtracting a 0, so I don't have to worry about that. Now negative and negative, that becomes positive 3 times cosine inverse 1. Cosine is 1 when the angle is 0. So that is 0. So that is equal to 3 square root of 3 minus 3 and 3 divides out. And we are left with pi there. And 3 times 0 is 0. So the only result is 3 square root of 3 minus pi. So that is the value of this definite integral given here. Example, evaluate the indefinite integral dx over square root of x squared minus 25. If we look at this integral carefully, it has x squared minus 25 which is similar to x squared minus 5 squared or x squared minus a squared. Because this integral involves x squared minus a squared, we can evaluate this using the substitution x equal to a secant theta. So this is the substitution that we want to make and evaluate this integral. So let's begin with that. Let x equal to a secant theta. In place of a, we have 5. So x equal to 5 secant theta. Then if we find the derivative, dx is equal to 5 is a constant. The derivative of secant theta is secant theta tangent theta. Secant theta times tangent theta. Also, you can note this one. This can be written as secant theta equal to x over 5, or you can also write this as cosine theta equal to 5 over x. Now, using the information, we are going to create the right triangle. Okay, now let's make the right triangle to represent this information. So I'm drawing that triangle here. Opposite, that's adjacent, and this is the hypotenuse. I'm going to name this triangle as triangle ABC with reference angle theta and right angle at B. Cosine theta is 5 over x. Cosine is adjacent over hypotenuse. So adjacent is 5 and hypotenuse is x. Now the missing side will be, we can find the missing side using the Pythagorean identity. So it will be square root of x squared minus 25. Square root of x squared minus 25. And we are going to use this information to make the substitution over here. So let's see what we get by making that substitution. So we have integration in the numerator, that is dx. Dx is equal to 5 secant theta tangent theta. 5 secant theta tangent theta divided by square root of, in the denominator, there is x squared minus 25. X is squared. X is 5 secant theta. And when you square that, it will be 25 secant squared theta. 25 secant squared theta minus 25. So we made this substitution. In next step, we are going to simplify this. This is equal to, in the numerator, we have 5 secant theta tangent theta. In the denominator, inside the square root, 25 is a common factor. We can factor that out. And we are left with secant squared theta minus 1, which is equal to integration of 5 secant theta tangent theta. I forgot one thing in the numerator. Dx is 5 secant theta tangent theta d theta. So we must have that d theta. Because when you find the derivative here, it is dx over d theta. And when you carry that d theta to the other side, it will multiply there. Divided by, in the denominator, is square root of 25 is 5. Secant square theta minus 1 is tangent square theta. But we have the square root. Square root of tangent square theta is tangent theta. That is tangent theta, which is equal to, now from the numerator and denominator, you can cancel 5 and tangent theta. So when you cancel 5 and tangent theta, you are left with secant theta d theta. Secant theta d theta. And we know that the integration of secant theta is natural log of secant theta plus tangent theta plus c. So that is my answer in terms of theta, but the question is given in terms of x, so I have to write the answer in terms of x. So I'm going to make that substitution. That's equal to natural log of secant theta. Value of secant theta is x over 5, x over 5, plus tangent theta from this right triangle. Tangent theta will be square root of x squared minus 25 over 5. Square root of x squared minus 25 over 5, then plus c. So that is the value of the indefinite integral given here in this example.